Well, hello everybody. Well, sorry I'm not there, or sorry you missed class, whichever one may occurred. What I need to do with you is I need to cover with you section 8-2. It's very similar to what we've already been working with, except for there's going to be an extra step in today because there's going to be a variable that shows up. So what you'll need in front of you is your class notes that looks very similar to that. So hopefully you got those in front of you. I will roll with this, and then if you need, just pause or rewind the video as needed. If you would look at your number 1 real fast. We've done this one before. I've got 5 over the quantity 2x plus 1 quantity squared, and we're going to find the antiderivative of that. We'll see if these steps sound familiar. I'm going to let u equal the quantity 2x plus 1. I'm going to say the derivative of u is 2 dx. And then I'm going to look at it and say, well, I need to see a 2 dx. And I would if I multiply by 2/5 and put a 5/2 out front. So then this becomes 5/2 antiderivative of u to the negative second, and then du. That 5 times 2/5 dx becomes my du. Now I want to pause for a second. Notice, guys, we needed a constant. You can introduce a constant whenever you want. The reason you can do that is you get to offset it out here. Now we're just going to go find our antiderivative. So this becomes u to the add 1, negative 1, multiplied by the reciprocal, and I still have that 5/2 out there. So it looks like this really becomes negative 5/2 u to the negative 1. So my ending answer, negative 5 over 2 u, which happens to be 2x plus 1, plus c. So you can introduce a constant whenever you want. But peek ahead now for number 2. Number 2 is different because there's going to be an extra x in there. So check this out. I'm going to let u equal x plus 1. And then just a little notice here, guys. I wanted this to be a squared right there. So if your worksheet's not a squared, put a squared on that, if you would, just to make things easier. Not sure if I fix that on your worksheet or not. Now, my du then becomes 1 dx. Now, I want you to notice this, though. Notice that there's extra x in the way. When I sub here in a little bit, this is going to become u squared. But I got this x right there I need to deal with. Whenever that happens, here's going to be our steps. Come up to your u equal x plus 1 and solve that for x. If I solve that for x, I'm going to get x equal u minus 1. Now, here's our steps now. I'm going to put all of this in terms of u. So it's going to become the antiderivative of, in place of x, I'm going to put u minus 1. In place of x plus 1, I'm going to put a u, and it's squared. In place of that 1 dx, I'm going to put a du. Now notice everything is in terms of u now. Now what I'm going to do is simplify this and find the antiderivative. So I'm going to think of this as u over u squared. So I'm going to need to find the antiderivative of 1 over u minus, and I'm going to think of 1 over u squared as u to the negative second. And then technically there's a little du out there. I went ahead and left the first one as 1 over u, hoping you would recognize that as the natural log. So the antiderivative of 1 over u is the natural log of u. Now let's go get this antiderivative. So I got a negative in there. Let's add 1, multiply by the reciprocal. So it looks like my two negatives are going to become a plus. Here's my final answer. I'm going to have the natural log of u. And then in this case, u happened to be x plus 1. So I've got the natural log of x plus 1 plus, now let's take care of that, 1 over u, which happens to be x plus 1 plus c. So there's that one. So it's a little bit different. What I've done here, guys, on the next slide is I just listed the steps for you. We'll practice them 6 more times before we're done with the video, so you'll catch them. But once again, let u equal your quantity, find your derivative, introduce any constant as needed. We've been doing that. Here's the new part of the day. If there's an extra x term, solve your u expression for x and substitute it in, and then simplify it. Once you see a couple more, you'll start getting the hang of it. Here comes your number 3. I've got the antiderivative of x times the square root of x minus 1. So here goes. My u is going to be x minus 1. My du is going to be 1 dx. So I don't have to introduce a constant yet, but I do have an extra x. So that means I'd need to do that extra step. So if I solve the top equation for x, I'm going to have x equal u plus 1. Now it's going to look like this. I'm going to have the antiderivative of, in place of x, I'm going to put u plus 1. I'm going to take care of the square root of x minus 1 as u to the 1/2. And then that dx becomes my du. Now our next step is we're going to simplify this. So this becomes the antiderivative of u to the 3/2 plus u to the 1/2 du. All I did there, guys, is I distributed that u to the 1/2 in. Now we're off to the races. I'm going to add 1 to the exponent, so I got u to the 5/2, and I got a 2/5 out front, plus add 1 to the exponent, so I'm going to get 3/2 multiplied by the reciprocal of 2/3. Final answer becomes 2/5 u, which happens to be x minus 1 to the 5/2 plus 2/3 x minus 1 to the 3/2 plus c. So there's our steps again. Here's our number 4. Once again, there's a quantity involved, so that means I've got a u substitution going on. So my u becomes 2x plus 1. My du becomes 2 dx. I've got an extra x there, so watch how I solve this for x now. I'm going to subtract away the 1, divide by the 2. That's what my x is going to be. Now be careful when we sub and everything. Let's take care of this. I need to see a 2 dx and I don't. So I'm going to introduce a 2, which means I need to offset that by 1/2. So I've taken care of that part. Now let's sub everything in. So I'm going to have 1/2, the antiderivative of x, which happens to be u minus 1 over 2. And notice that 2x plus 1 to the 4th in the denominator. I'm going to keep it in the denominator as u to the 4th. And then that 2 dx becomes my du. So there's what it looks like subbed in. Let me make my messy 4 a better looking 4 for you. I'm trying to use an Interwrite program and it's just not as smooth as my PowerPoint. Okay. Now, I'm going to simplify this so that I can find the antiderivative. So guys, what I'm going to do is I'm going to distribute in this 1/2. So I'm going to think of this as u minus 1 over 4u to the 4th. Now I'm going to split it up so I can find the antiderivative of it. So this becomes, once I split it up, I've got u over 4u to the 4th. So I'm going to have 1/4 u to the negative 3rd minus 1/4 u to the negative 4th. So I just moved that 1/2 in so I didn't have to mess with it later. And then I split them up, 1/4, brought that up after I simplified. Now, let's go find our antiderivative. So I'm going to add 1 and get a negative 2. So I've got a negative 1/2 out there, and I still have a 1/4, which I'll combine here in a minute, minus. Let's add 1, so I got a negative 3. Means I've got a negative 1/3, and I still have that 1/4 to sub with. Well, here goes my ending answer. 1/4 times negative 1/2 is negative 1/8. So I've got negative 1/8. And in the denominator, I have u squared, so I've got 2x plus 1 squared plus 2 negatives made a positive, 1/12 u, which happens to be 2x plus 1 cubed plus c. So there's my antiderivative. What we're really doing, guys, we are undoing the product rule here. I could factor this and show you that the original statement would be something we'd find the product rule of. So I've got 2 more coming your way, then I've got a couple with numbers. Those are nice because you can check those. But here goes your number 5. I'll just see if I can pick the pace up a little bit. My u happens to be 3x minus 1. My du happens to be 3 dx, so I'm going to pause for a second. I don't see a 3 dx, so I'm going to introduce a 3, and I'm going to have to offset that with the 1/3. Now I also notice I have an extra x in the way, so let's solve this thing for x. So x is going to be u plus 1 over 3. That's going to be my x statement. So now, guys, here goes. Let's sub that in. So I've got 1/3, the antiderivative of x, which happens to be u plus 1 over 3. Let's take care of that square root of 3x minus 1, so I've got u to the 1/2. That 3 dx becomes du. Now, before I work with this, I'm going to go ahead and distribute that 1/3 inside. So I'm going to think of this as the antiderivative of u plus 1 over 9u to the 1/2 du. We don't have to move that in right away, but you're going to have to distribute it later. So I'm just getting that out of the way. Now, let me rewrite this so we can find the antiderivative. So I've got the antiderivative of. Let's look at that u over 9u to the 1/2. So I'm going to have a 1/9 in there. U to the first over u to the 1/2 looks like a u to the 1/2 plus 1/9 u to the negative 1/2. I just brought that up. Now let's go get our antiderivative. So I'm going to add 1, so I'm up to a 3/2. I'm going to offset it with the 2/3, and I've got a 1/9 plus, add 1, I'm at a 1/2. I've got a 2, and I've still got that original 1/9. Ending answer, 1/9 times 2/3 looks like 2/27. U, which happens to be 3x minus 1 to the 3/2 plus 2 times 1/9, so I'm at 2/9 times 3x minus 1 to the 1/2 or square root, whatever you want to write, plus c. So there's my antiderivative of that. Here's one more like it, and then number 7 and 8 is very similar, but I want to show you how you can change some boundaries if you'd like. So here goes my number 6. I spy a quantity, so u equal x plus 1. Du equal 1 dx. So on a piece of good news, I don't need to introduce a constant, but there is an extra x, and notice it's really an x squared. So let me solve that for x up there. So x is going to be u minus 1. Well, look at what happens once I sub this in. I'm going to have u in place of the x, so I'm going to have u minus 1, but I'm going to have u minus 1 squared over u cubed. U minus 1 quantity squared over u cubed. And technically a du right there. This really becomes the antiderivative of, I'm going to FOIL out that numerator and get u squared minus 2u plus 1 all over u to the third du. I'm going to simplify this. U squared over u cubed, I'm going to write that as 1 over u, hoping that you recognize the natural log. And I've got minus 2u to the negative second plus u to the negative third. And then there's my little du out there. So now let's go get this antiderivative. So 1 over u, that's our natural log. So I'm going to have the natural log of u. For this guy, let's add 1 and get negative 1. Multiply by the reciprocal out there and the negative 2, so it looks like I'm going to get a plus 2u to the negative 1. Plus, add 1, I got negative 2. Offset that with the reciprocal, negative 1/2. So it looks like my ending answer. I've got the natural log of u, and u happens to be x plus 1 plus 2 over x plus 1 minus 1 over 2u, which happens to be x plus 1 squared, plus c. We wound up having 3 pieces on this one because when we FOILed out that numerator, we got 3 pieces. So there's where we are so far. Number 7 and number 8, guys, are the same thing, but I want to show you how you can change some numbers if you'd like. So here goes number 7. This is called a definite integral because we're binding it with some numbers. Just like you guys did when we shaded the area and found it. You could also check this on your calculator and make sure you got it right. So these are nice. But here goes your number 7. My u is 2x minus 1. My du happens to be 2 dx. I've got an extra x, so let's solve that for x. X is going to be u plus 1 all over 2, just like we've been doing. Now when I sub this in, I'm going to leave the numbers off for a second. So my x happens to be u plus 1 over 2. And I happen to have square root on the bottom, so I'm going to write u to the 1/2 on the bottom, du. Just like we've been doing. Now let's go ahead and simplify this. So I'm going to think of u over 2u to the 1/2 as 1/2 u to the 1/2. I subtracted my exponents. Plus 1/2 u to the negative 1/2. I just brought that up. And I almost forgot this. Notice this 2 dx up here. I needed a 2 there, and I needed a 1/2 there. So technically there's a 1/2 out here. I almost overlooked that. So what I'm going to find the antiderivative of here in just a heartbeat is going to be 1/4 u to the 1/2 plus 1/4 u to the negative 1/2. So here goes. Let's add 1 and get 3/2, 2/3, and I've got that 1/4 out there. Then I've got plus, let's add 1 again, so that's going to be 1/2. So 2 times a 4th looks like a 1/2. Now guys, here's where the trick's going to come in at. Usually what I'll do is I'll simplify this, and I'll simplify that 1/4 times 2/3. But normally we sub in 2x minus 1 here. What I'm going to do is a little trick that makes things a little easier. I'm going to go ahead and go 1/4 times 2/3, and I'm going to get, what, 2/12, so I'm going to get a 1/6. This becomes a 1/6 u to the 3/2 plus 1/2 u to the 1/2. Now instead of subbing in 2x minus 1 in place of my u, what I'm going to do is I'm going to change my boundaries. And here's how I'm going to do this. My new lower boundary, see this 1 right here? I'm going to plug it right there for x. 2 times 1 is 2, minus 1 happens to still be 1. Now let's plug in your 5. 2 times 5 is 10. 10 minus 1 is 9. Now what I can do is I don't need to take that step and sub in 2x minus 1 in place of my u. I have this thing in 100% terms of u, so now I can just do this. When I run that 9 through there, I'm going to get 1/6 times 9 to the 3/2 plus 1/2 times 9 to the 1/2, which we know is 3. So there's the number I'm going to get when I run 9 through there, minus when I run 1 through there, I'm going to get 1/6 times 1 plus 1/2. When you run all this through your calculator, you should come up with positive 16/3. Looks like a negative because I got a smudge there. Okay? Now guys, if you don't like changing your boundaries, that's no big deal. What you would have done, I'm going to get a little room right here. You would have just done this. You would have said, Mr. Harris, I don't like that, so I'm going to think of this as 1/6 times 2x minus 1 to the 3/2 plus 1/2 2x minus 1 to the 1/2, evaluated at 1 to 5. But watch what you're going to get. When you sub a 5 in here, 2 times 1 is 10, 2 times 5 is 10, minus 1 is 9. Notice that 9 shows up. So it's just a step to save. I'll do one more, then my video is going to be about 25, 26 minutes long, so not bad. Here goes your number 8. So once again, there's a quantity involved, so my u is going to be x plus 4. My du is going to be 1 dx. That's nice. I don't need to introduce a constant, but I do have an extra x. So x is going to be u minus 4. Let's sub that in. So I'm going to have the antiderivative of x, which happens to be u minus 4, squared times u to the 1/2 du. Now, I need to FOIL out that quantity squared. So I'm going to get u squared minus 8u plus 16 times u to the 1/2 du. Now let me distribute. So I've got the antiderivative of u to the 5/2. I added those exponents. Minus 8u to the 3/2 plus 16u to the 1/2 du. Now let's go get our antiderivative. So add 1, it looks like I'm going to have a 7/2. So I'm going to have 2/7 u to the 7/2 minus, add 1, looks like 5/2, multiply by 2/5 and get 16/5 plus u to the 3/2, multiply by 2/3, and looks like I'm going to get 32/3. And then I'm going to evaluate that from, plug in 0 for x, and get a u boundary of 4. Plug in a 5 and get a 9. And then it's all calculator work from here. Run 9 through that quantity, run 4 through that quantity, and then you'll get your answer. The ending answer winds up being 12,154 over 105. But I won't take video time to run those through for you. So guys, there's the u substitution. Hope it made sense to you. If not, we'll get you straightened out as soon as I see you. Good luck to you.